Good day, viewers. Here is another question on mechanics, motion of projectile particles. Alright, so the question reads, a farming relief aircraft flying over horizontal ground at a height of 160 meters drops a sack of food. First question, calculate the time that the sack takes to fall. Now B, calculate the vertical component of the velocity with which the sack hits the ground. Then C, if the speed of the aircraft is 70 meters per second, at what distance before the target zone should the sack be released? Okay, so a farming relief aircraft flying over horizontal ground. Okay, so let's see how, at a height of 160 meters, drop a sack of food. So that means that this is what we have. We have a farming aircraft. Let me draw it this way. This is a farming aircraft. We have a farming aircraft. The height of the aircraft, okay, to the ground, the height is 160 meters. So this is the horizontal ground level. That's the horizontal ground level. Okay. So now we have that the height of the aircraft is 160 meters above the ground. Okay. So calculate the time that the sack takes to fall. So to calculate the time it takes the sack to fall in this case, we can see here that this is a vertical motion. That is, it will be vertical motion because the aircraft, okay, drop, let's say this is the sack, it drops, let's say it drops the sack, to the ground, okay. So which means, and we know that the height of the plane, okay, that's the aircraft to the ground, is 160 meters. So for vertical motion, so let's write the equation that can be modeled for for this, that is to be able to calculate the time that the sack takes to fall. So it means that we know from here that since it is vertical motion, okay, we want to calculate, okay, let me write this first. We want to calculate the time, okay, it takes the sack, this time it takes the sack to fall. So for vertical motion, remember this, for vertical motion, okay, u will be equals to what? 0. Okay, u will be equals to 0. So the value of u is equals to 0. And we know that in this case, because the sack is dropped, to the ground, that is, it is dropped, that's the aircraft dropped the sack to the ground. So that means that it will move downward because, as it moves downward, the value of g downward will be what? Will be positive. So which means we are going to use one of the equations of kinematics, which is, now we know that height h equals to ut plus 1/2 of gt squared. Okay, now we know that the value of h is 160 meters. Now the value of g in this case is positive, so that will be positive 9.81 meters per second square. Now we want to find the value of time t. So like I said, because the aircraft drops the sack to the ground, okay, it will move in the direction of gravitational acceleration, that is acceleration of free fall, okay, because the object is dropped to the ground level. So now, it means that the value of g will be what? Will be positive. So to calculate the value of time t, of course, we can use this formula because when we make t the subject of the formula from here, after we substitute the value of u, which is what? 0, we're going to have t to be equals to the square root of 2h over what? Over g. All right, so in this case, t will be equals to the square root of 2 multiplied by 160 divided by 9.81. so that time t will be equals to the square root of 360 multiplied by 2. That will be 320. So let's divide that by 9.81. Okay, so 320 divided by 9.81. Okay, 320 divided by 9.81. So that will be what we have as 32.62. Okay, so t will be equals to the square root of 32.62. Now let's get the value for what is the square root of 32.62. The square root of 32.62 is 5.71. So the time it takes the sack to fall will be 5.71. That will be 5.71 seconds. So this is the time it takes the sack to fall. And that's the answer to the first question there. All right, so B. Now also, we want to calculate the vertical component of the velocity with which the sack hit the ground. So for vertical component, okay, we're also going to use one of the equations of kinematics, and that will be this equation. We're going to use V equals to U plus, that is Uy, Vy plus gt. Okay, now we know the value of t to be 5.71. okay, and also we know that the value of g is positive when the motion is what, when it is vertically downward motion. Okay, so and also we know that the initial vertical, that's the vertical initial velocity will be what, 0. That means uy will be equals to 0. So this guy is what we need to find out. So we need to find the value of Vy. So we have Vy to be equals to 0 plus 9.81, then multiply by 5.71. 5.71. So that Vy will be equals to, what is 9.81 multiplied by 5.71. That will be 56.03. That will be 56.03 meters per second. So we can write Vy approximately, it will be equals to 56.0 meters per second. So this is the vertical component of the velocity with which the sack hits the ground. All right, so next we have also, if the speed of the aircraft is 70 meters per second, that means the speed of the aircraft, remember the aircraft is what, is moving horizontally, so its velocity, okay, will be 70 meters per second. That will be horizontal velocity. So then at what distance before the target zone should the sack be released? All right, so it means let's x represent the distance, okay, and we know that distance is what, horizontal component of velocity, or the horizontal velocity, okay, multiplied by what, time of flight. Okay, because the question reads, if the speed of the aircraft is 70 meters per second, at what distance before the target zone, okay, should the sack be released? Okay, so that's why it is important to use t, the same value, 5.71. So now, and because we know that velocity measures distance traveled over time, so if we make x the distance, the subject of the formula, so we can have x equals to horizontal velocity multiplied by what, time. Okay, so we know that horizontal velocity is what, 7 meters per second, while the time is given to be is what, is 5.71 seconds. So that x will be equals to 70 multiplied by 5.71. Okay, so what is 5.71 multiplied by 70? That's 70. That'll be 399. 5.71 multiplied by 70. That'll be 399.7. So the distance will be 399.7 meters. 399.7 meters. That is the distance before the target zone. That is we have at what distance before the target zone, okay, should the sack be released, and that is the distance before the target zone it should be released will be 399.7 meters. The noblest pleasure is the joy of understanding. Bye bye.